thank you all for coming. My name is Irina, and I'm a software engineer at DevWorks, where our team developed Langium as well as involved in cloud IDE development with Theia and VS Code. And today we are speaking how to use Langium to create DSLs in the cloud. First of all, what is a DSL, or domain-specific language? It's a language specialized for solving problems of a certain class. Such as managing data held in relational database, SQL, matrix programming, MATLAB, multi-project builds, Gradle, document layout, LaTeX, and many other. And like the GPL, general purpose programming languages such as C++, Python, Java, these cells cannot be applied to every possible task and are limited to their domain. And this is a feature of these cells. So, concentrating on a concrete domain gives some positive effects. For example, the cells are more expressive. So, the result, high abstraction level gives you ability to focus on the problem and not on the implementation details. In addition, some domain knowledge give you ability to make better validation. You can put it in domain level and have very nice error messages. Also, additional domain optimizations that you can make can give you higher performance. Finally, the DSL code is much more simpler than the code that you would write in general purpose language with the same functionality, and it can be shown to your non-programmers colleagues. For example, to demonstrate solution of some business problems. Okay, now, when we know DSL advantages, maybe we want to create our own DSL. And how to do that? Here is the pipeline how you can do it. It contains 4 stages. So the first stage is an idea. You need to come up with some nice idea for your DSL, some special properties that some killer features that make your DSL interesting for other people. Next stage is design, in which you have to think how your DSL looks like. So which keywords it has, which syntax, or the semantic of your DSL, how it can be interpreted. Next stage is implementation. You need to implement your DSL in code. And this stage can be iterative. Finally, in the last stage, you should integrate your DSL in some existing IDE that people will be able to use it. Okay, we discussed the stages, what tools that we need to use to implement each of the stage. If the first 2 stages are relatively clear in terms of implementation, you just can use pen, paper, and your brain, your time, and everything will work. And the last stage is also clear, you can use Theia. The question which tool to use for the implementation stage is still open. To say that your DSL is implemented, you need to satisfy many requirements. Basically, they can be divided in 2 sets. It's language requirements and IDE requirements. Language requirements are related to the language functionality. So, how to take plain text of your DSL and transform it in something functional. It includes such things like parsing, validation, linking, scoping, interpreting, and many other things. Otherwise, IDE features can be called in some sense optional. But remember how you write code in your favorite programming language, which is general purpose language. So you use many wonderful features by IDE, like find reference, code to definition, renaming, code completion, hovering. And so many nice features that would be very nice to implement for your DSL too. That people who use your DSL also enjoy writing code in it. One problem that you need to resolve is choose IDEs for which you implement your features and re-implement these features for each IDE. The problem is that different IDEs can have different APIs. And yeah, you have to re-implement these features. So to summarize problems that we have implement language features, IDE features, and to implement all those features for some IDEs. What to do? Basically, you can do it manually. You just can sit and write very much code and get perfect result. However, I can propose you better solution. So let's start with the re-implementing. We can use language server protocol. What is it? Language server protocol, or LSP, is a JSON RPC protocol used to connect an IDE and a server that provides programming language features. The idea behind it that it unifies a way how language servers and IDE interact. And as a result, you can write only one language server for your DSL and reuse it in many IDEs that also support language server protocol. Okay, we know how to resolve problem of re-implementation. We can use LSP. And in addition, thanks to this, we get more information about our implementation tool. Yeah? So how can we implement our DSL? We already definitely know that it has to be something that supports the LSP. So basically, we're still able to do everything manually. Let's support language server protocol. But there's better solution. We can use Langium. So Langium is a language engineering tool that, written in TypeScript and runs in Node.js, uses Chevron under the parser hood, has grammar declaration language similar to Xtext. But the main thing, it supports language server protocol and provides high out-of-the-box functionality. What it means, Langium is able to generate feature services. This is exactly what we need. So let's look how it's working. Langium takes your DSL as an input and generates Metamodel. It's some internal representation of your DSL, and basically it's typed abstract syntax tree that in addition have a bunch of functionalities to navigate and process the abstract syntax tree. Then Langium generates feature services based on this meta model. Okay, it's great, but we wanted something for the cloud. Is Langium good for the cloud? Yes, Langium is ideal for the cloud. Langium supports language server protocol, which allows to generate plugin that will be supported by different IDEs, including Theia. Langium is written in TypeScript, which makes technology stack more consistent when you work in web. Also, Langium have low overhead compared to other tools in this area, and it's very important when you're working in web. Finally, Langium can be used in front-end editors like Monaco as well as in backend processes. Thus, Langium is added to our diagram, and all gaps in our tools, in our pipeline, are filled. However, we can modify this pipeline thanks to one more advantage of Langium. Langium has a grammar-driven approach which enables rapid prototyping. And as a result, instead of writing your DSL design informally, you can use Langium for that and write it formally using grammar. Write the first partial prototype and iterate until you are satisfied by the syntax. Quick advantage, you can have ready DSL in any moment in your IDE, as in each of this iteration you can work on it in IDE. But all this is just words. Let's look at the concrete example. In our demo, we consider some small language state machine. To start with, the first stage of our pipeline is an idea. The idea of this DSL is describe state machines. So And as example, we consider some state machine as traffic light. So it has four stages. We start with the idea stage. The idea of the state machine DSL is describe state machines. This is for what this DSL will be created. And let's consider some example of such state machines that can be described. It's called traffic light. So it has four states: red light, yellow light, green light, and power off. And transitions can happen thanks to two events: it's next and switch. And also we have initial state as power off. Let's look at the transitions. So from power off, we can get red light by switch event. And from red light, we can get green light by next event. And then also using next event, we can get yellow light state and red light state again. And finally, we can get power off state by switch event from each colorful state. Okay, great. This is how it looks like our idea. What about the design? So on the left side, you see the codes that describe state machine traffic light. Colored box highlights places where concrete states are described, as blue box describe power off state, red light is marked as red light, and so on. Okay, the state machine DSL example that we see here, it's only an example. So basically you can create your own state machine DSL that have other keywords and other syntax, whatever. But anyway, let's consider closer this proposed syntax. First of all, we have a state machine name in the beginning. It is defined thanks to keyword state machine, and then we have name of our state machine. In our case, it's traffic light. Then we have event list. So it's also use some events keyword, and then we have list of events. Then we have initial state name and set of states. In its turn, each state is described by its name and transition list. And finally, we can extract components. So what do we have here? We have keywords and symbols. So here is state machine, events, initial state, state, and an arrow. And also we see here some entities. So it's state, like entity, it's transition, event, and state machine by itself. In addition, each of this entity has its own properties. So, for example, properties that important for state is its name and list of transitions. Properties that important for all state machine by itself is list of states, list of events, initial state, and of course, name of the state machine. Okay, now when we know many things about our DSL, we can go to the implementation stage. And that magic would happen. And Langium can write everything. We need to write grammar of our DSL. And for that, we need to initiate a DSL plugin with Langium. So our first step is start wizard, and it will propose you to answer 3 questions about your DSL. It's your extension name of your project, basically. It's your DSL name, and finally file extension for files that will contain code snippets of your DSL. The last step that you need to do is open the grammar file. It's already generated by grammar and will exist in each project. to the same path. And also grammar file has an extension .langium. Okay, we opened our grammar file and wrote our grammar based on our investigations of the design stage. And we have here and keywords and symbols and all necessary entities. Let's take a look at it closer. So what do we have here? Our grammar starts with keyword grammar and then name of our domain-specific language. In our case, it's state machine. And then we have sets of parsing rules. So we had our entities, and now we have representation of each of these entities in these parsing rules. So we had a state entity and have state rule, event and event rule, and so on. In addition, at the bottom, we have some special terminal rules. They are representing tokens. So basically, it's the smallest meaningful element in our DSL. And here we have two such things. It's WS or white space and ID or identifier. At the bottom there are terminal rules that describe tokens, the smallest meaningful elements that our DSL can be divided into. We have here two terminals, it's WS white space and ID or identifier. They defining by regular expressions and usual parsing rules, defining using keywords, assignments, and rule calls. Assignments can be understood like properties of our entities. Basically, what is interesting for us for state entity? We're interested in its name and list of transitions. And if you take a look at parsing rule state, you really can see that names of assignments here is name and transitions. Matching each element from this grammar with our traffic light example can help us understand the grammar better. So on the left side, you see the state machine, the cell code snippet that describes traffic light state machine. Let's match each this element with the grammar. So our code snippet starts with the keyword state machine and name of our state machine. So this is what we can see inside of the rule state machine. This is an entry rule from which we start parsing our DSL code snippet. And here we really see state machine keyword and assignment. With rule call identifier. So this is where we wait for name of our state machine. Then we have the event list. It is described by events keyword and then rule call event and assignment events. But we can notice that this assignment is not just equal sign how we saw it before, but plus and equal sign. It says us that we want to have here not just one event, but maybe some events. And such type of assignment is called array assignment. In its turn, each event is described by a rule event. Then we have initial state. It's described by keyword initial state and also assignment init and rule call state. And finally, we have a list of states that is described by array assignment states and rule call state. Each state is described by concrete parsing rule state, where we can see two keywords, state and end, one assignment name and one array assignment conditions. And instead we see also transitions list, where each transition is described by parsing rule transition. You may notice that some rules are enclosed in square braces while others not. Rules that are enclosed in square braces are called cross-reference. and they have other functionality comparing with usual rule calls. When we write a rule call, we are waiting for some definition of this rule. So something that can be parsed by this rule. Otherwise, when we use cross-reference, we are waiting for that in this moment will be used the only name of already defined entity. So basically, we have a reference in this moment. So, for example, we have two different rule calls of state parsing rule. And in one place we had it with square braces, so it was cross-reference actually. And another place we had it like usual rule call. What is the difference? When we had it like usual rule call, it was the case when we wanted to have a list of states. So for each this rule call, we got full definition of one state, and we had four states: power off, red light, yellow light, green light, and otherwise, when we used it like a cross-reference, we did it for initial state. We wanted in this moment have the only name of some existing state that can be defined any other places. But actually, if you want only name, we could use just identifier in this moment for parsing. Yes, it's true. But identifier has less functionality than the cross-reference can provide. Thanks to cross-reference functionality, Langium is able to build very precise metamodel. For example, you can see a metamodel that is built for the state machine entity by this parsing rule. You can take a look at the init property and states property. To have these properties, we used two assignments, states and init. For both of them, we use this state rule. But for one case, we used it like real rule call. For another case, we use it like cross-reference. And all this is reflected in our meta model. So you can see that for states, we have it like just usual state in a type. And for init, we have really word reference. So Langium knows that here will be reference an existing object. And such functionality allows Langium to generate many feature services related to references, such as find reference, go to definition, and many other. Okay, now when our grammar is finished, we can come to the generating the DSL implementation with Langium. For that, we need to be in our project directory and run Langium generate command. Yay, now everything is ready and we can go to our last stage about IDE integration. And for that, to inject the Langium created plugin in Theia, we need to make 3 steps. First of all, let's create VSX file, then start Theia and add the state machine. Making these 3 simple steps give us Cloud IDE for our DSL. So we can conclude that Langium is ideal for the cloud. It helps you implement your DSL easily and quickly. Supporting language server protocol will allow you to reuse your language server for your DSL in many IDEs that also support language server protocol. And in addition, it has web technology stack, what is perfect for the cloud. Thanks for your attention.
Hi. So I'm ready for the QA session, and I got some questions about Langium. So first question, which I like to answer, is a question by Trina Graham. So does Langium relate to Xtext? Is transitioning from Xtext to Langium possible? So the answer to this question is yes. Xtext was created by actually, in some sense, the same people who create currently Langium by our team, the SAE team. And people in our team were inspired by Xtext. So Langium is like continuation in some sense of Xtext in another technology stack. And as a result, Langium inherit some things from Xtext and improve some things. So basically, how I mentioned in my slide about Langium, Langium has the same grammar, very similar grammar that Xtext has. And as a result, it has to be not so complicated to migrate your project from Xtext to Langium. So you just basically catch the same grammar, make some modifications, and that's all. Currently, we are working in our team on writing some guide or maybe even some code actions, how to translate your Xtext project to Langium simpler. So next question is by Philip. How is the abstract syntax tree represented? Can it also be processed or even modified by other components with updating the textual file on change? Abstract syntax tree in Langium looks like a set of interfaces written in TypeScript. So on last slide, one of the last slides, you could see how it looks like with this state machine example. So, and as a result, when you handle this object syntax tree, you can work with it exactly like you do it with any TypeScript interfaces, what can be very comfortable. In addition to just these interfaces, you have some helpful functions to navigate over your tree, some reflection, and some basic methods, basic properties that each node of the subtract syntax tree has. Next question is by Tim. Hi, Irina. Thank you for the talk. Thank you for listening. Could you tell us a little about Langium adopters and what sorts of DSLs they have been creating with it? So currently we use Langium very actively in our client project, with our DevFox team. And we already proved that Langium can be used for very different DSLs. Examples of the DSLs we could see, for example, in our repository for Langium. Now, examples directory. So you can really see that there are very different use cases. For example, we have the state machine that I told today that I described in presentation. We have domain model example, so how you can describe some classes similar to Java classes. So we can just have names and some property names, or you can describe some expressions. So basically, you can describe with Langium whatever you want. Key moment that's necessary to keep in mind is what you decided to pull in area of DSL. So you have to be very careful about the idea that you use. It doesn't have to be too complicated, because in this situation it's better to use just a general purpose language. But in the same time, it doesn't have to be too simple that useless to create some DSL. Give me more questions, maybe in some personal chat if you want to know more. I actually can't say more detailed about our client projects. Because we are not able to share this information. Next question is also by Philip. Do you think it could be possible to run a Langium language server not based in the browser as a web worker? For example, by abstracting file access into an API. So yes, actually, we do that and plan to do that for a public Langium playground in the browser. So it's some our future step. Okay, I'm really looking forward to more questions in the chat, and I'm always happy to discuss projects. Our project Langium. I'm really very happy to work on it. So just write me. Thank you.